Hi guys, welcome back. We are starting lesson 5.2, dilations not from the origin. So how can you draw a dilated image? You would multiply by the scale factor around a fixed point P. That fixed point is called your center of dilation. So let's take a look at this little example. Here's my center of dilation. Step 1, it says to draw rays from P through each vertex of the corresponding, like B prime corresponds to B. Same thing with A and A prime and C prime. Okay, so now mark point A at a point that is half the definition. So we're going, or half the distance. So we started by going from P to B basically, or P to A and P to C. Then what you do is you measure the distance from P to B. And since we're going to only go half that distance, use your scale factor, multiply that distance by half, and then measure from B and plot a point for B prime that is that distance away. You would follow the same procedure here. Measure from A to P, multiply by half, and then use that measurement from P to A prime. Measure from P to C, multiply times 1/2. Use that measurement to go along that ray and plot point C prime. And then you end up with a triangle that is half the length. It's been dilated, half the size of the original, and the center of dilation is P. Remember that a reduction is when your scale factor is between 0 and 1, and enlargement is when it's greater than 1. When you have a situation like this, notice that from P, our original, to C, that is 6, and from our image, P prime, to our original is 3. So remember, our scale factor is always our image over our original, also called our pre-image. So this was our image over our pre-image, and that gives us a scale factor of 1/2 for this reduction. For this one, we go from our point of dilation, our center of dilation, 2 units out to P. Well, from our center of dilation all the way out to P prime is 5 units. So remember, our image is on top, and there's our pre-image. So we have an enlargement where our scale factor is 5/2. Always remember that P prime, Q prime, your prime is your image over your pre-image. Okay, so now let's take a look at this one. When I'm looking at this, I'm going to think about my image over, I like to say, original. So I'm thinking, okay, from C to P prime, that is my image, which is 12, over my original, which is 8. So now I reduce that, and K equals 3/2, and I have an enlargement. I want you guys to try the next one. You try this one. Pause the video. Come back, and let's see how you did. All right, so now let's take a look at this situation. Where would A prime be if we're dilating by a scale factor of 2, so it's going to be enlargement? What I would do is I would measure from P, let's get a straight line. I would measure from P to A, and I actually did do that with my ruler, and I came up with a 15 millimeters. 15 times 2 is 30. So I would actually continue on another 15 millimeters from A, try to make this continue a straight line about the same. And that's where A prime would be. And from A prime all the way back to my center of dilation would be 30 millimeters. Okay, so we're going to use that ratio method to dilate this little triangle JKL by a scale factor of 3, so it's going to get larger. I already measured all of these. Here's my center of dilation. I already measured all of these with my ruler, and I wrote them down. Well, with a scale factor of 3, that means I'm going to multiply each of these by 3. So this would be 15 millimeters, 24 millimeters, and 45 millimeters. Well, I want to stay along the same vector or the same line. So I measure out to here. This is going to be my K prime. And from K prime to R is 15 millimeters. Stay along the, using a ruler, measure out to here. There's going to be my J prime, and this one will be my L prime. Again, measuring all the way out. Pay attention to how, I know I'm just drawing in, but JK and J prime K prime should be parallel. If I had a ruler, they probably would be. JL and J prime L prime are parallel. And KL is parallel to K prime L prime. Let's look at another one of these examples. This time it's with a reduction. I have measured already each of my points, like from P to M. Here's my center of dilation, and I've gotten my measurements. Now I'm going to be dividing by 3 or multiplying by 1/2 to get my reduction. So here I got 16.6 millimeters, 20 millimeters, and 7 millimeters. So now I'm measuring. I didn't just plot these any old place, okay? What I did is I went from kind of, this is a little out of whack, but I'm going from M to P. Let's take that back a little bit. I'm starting here and I'm going here, and this was from M to P, about 21 millimeters. Then I want to take and I want to plot, use my ruler, plot P prime, and it should be somewhere along here where it's only 7 millimeters. And so this is going to be P prime, this would be Q prime, R prime, using that ratio method of measuring. And again, look, think about the corresponding sides being parallel. Okay, here, my center of dilation, if I'm being asked how do you find it, I'm just going to take my corresponding points, such as this point corresponds to this one. I'm going to draw a line through it. I'm going to take this corresponding point and this corresponding point, draw a line through it. Same here. Take my corresponding points and draw a line through it. Where all the lines intersect, that is my center of dilation. Okay, here you can see I've already drawn in the lines, so I know that my center of dilation here is at 6, -6. Now my scale factor, remember, it's image over original. On the image, I'm looking at this side right here because it's really easy to count. I don't have to use my distance formula. And over here I'm counting, this is the corresponding side. So my scale factor is 1/4. Should be a reduction, and yes, my image is a reduction of my original. Over here again, I've drawn lines through my corresponding points or vertices of my figures. I've seen where they intersect. That's my center of dilation. Again, this was an easy count of 6 units, and this was an easy count of 3 units. So I'm looking at this, and my image is my 6 over my original, which is my 3. So my scale factor is 2, which means it should be an enlargement. And it is. Okay, kids, I want you to pause the video. I want you to try these. Make sure you printed them off. It'll be easier to do. And when you come back, I want you to check them. Let's see how you did. All right, moving on. If we're going to find our center of dilation here, we would just like connect J and J prime. Ooh, terrible, terrible, terrible. Okay. OCD is not going to allow that. So I'm just going to go ahead and try my best to do this. Connect my corresponding vertices. And where all of those points intersect, we'll call that, that's my center of dilation. So it is where all of the vectors or lines connecting your prime to your corresponding pre-images intersect. Again, well, this is just a reminder about your scale factor is the ratio of your side lengths of the image as well. You can take your image over your original, and that'll be your scale factor. You can also do that with your coordinates. Okay, the next one is for honors only. We're going to look at dilating about a point. That is not the center. We're going to be doing this on the coordinate plane. It is very much like the rotation and translations without using the origin as your center. So if I label these A, B, and C, and I write them out, first thing I want to do is translate this point right here back to the origin. In order to do that, I have to go right 6 and down 5. Again, it is just like subtracting this point, subtracting -6 positives. I'm going to get my little results here. And this is where I'm going to apply my scale factor. It was 1/3, so I'm going to divide it by 3. And then I have to translate it back. So I'm going to add my -6 and my 5. Plus my -6 plus 5. Same process we've used in the other ones. Okay, and then when I get my results, that's going to be my A prime, B prime, and C prime. And when you graph those at -1, 2, 3, 4, 5, 1, 2, 3, 4, 5, A prime, B prime, C prime. There you go, and it is a reduction. So if you follow the same, I want you to try to pause the video. Try to do the same with this point when you come back. See if for A prime, you end up with these coordinates. Lastly, we're dilating a point of triangle ABC as shown. So the original's in black, we did an enlargement in orange. When I connect all of my vectors of corresponding points, I find that point A is my center of dilation. To find my scale factor, all I'm going to do is take my distance from C prime to A prime using my distance formula, and then from C to A, that's my original, using my distance formula, and then I can find my scale factor. It was indeed an enlargement. The orange is larger than the black, so I would expect it to be greater than 1. Okay, if you have any questions or concerns, be sure to hit me up through It's Learning or get with me in class and let me know what's bothering you or making you struggle, and let's get it all straightened out together. Hope you have a great day, and I will see you next lesson. Bye.